Did AlphaZero really cheat? On 5th of December, 2017, the greater chess community was shocked. DeepMind Team's AlphaZero achieved superhuman level in just 4 hours of self-play and was able to defeat then chess god, Stockfish 8. In a time-controlled 100-game tournament, 72 games ended in a draw. AlphaZero won 28 games and lost none. DeepMind estimated that after only 9 hours of training the algorithm, it had a much better ELO rating than Stockfish. Released games were brilliant and showed very strong and human-like play. AlphaZero is a computer program that taught itself how to play chess, shogi, and Go. It was developed by Google-owned artificial intelligence research company DeepMind. The program is based on an algorithm known as Monte Carlo Tree Search, or MCTS. AlphaZero beat Stockfish by using a deep neural network to learn the game of chess. This allowed it to develop its own chess strategy, which was stronger than the strategy used by Stockfish at the time. GM Peter Heine Nielsen famously compared watching AlphaZero's games to seeing a superior species landing on Earth and showing us how to play chess. Garry Kasparov, former world chess champion, expressed his surprise by saying, "I can't disguise my satisfaction that it plays with a very dynamic style, much like my own." GM Fabiano Caruana said, "I was amazed. I don't think any other engine has shown dominance like that. I think it was 4 hours of learning, so who knows what it can do with even more." GM Sergei Karyakin expressed his surprise, "I am very much surprised because we normally work with Stockfish and it looks like it's a good program, but if we have a program which beats Stockfish so easily, it might be a new generation for computers and maybe it's a historical day for chess. We'll see how it will get stronger." But not everyone agrees with the dominance of AlphaZero. Some thought this was too good to be true. Today, people still believe that DeepMind cheated by using all of the power of Google's cloud infrastructure. Levon Aronian said, "I am very excited, but I am not sure about the conditions." And understandably, Stockfish developers were bitter, and thought the match was not on equal terms. Stockfish developer Tord Romstad talked about the match. "The match results by themselves are not particularly meaningful because of the rather strange choice of time controls and Stockfish parameter settings. The games were played at a fixed time of 1 minute per move, which means that Stockfish has no use of its time management heuristics. A lot of effort has been put into making Stockfish identify critical points in the game and decide when to spend some extra time on a move. However, if it only has a fixed amount of time to spend on each move, its strength will suffer significantly. The version of Stockfish used is 1 year old, was playing with far more search threads than has ever received any significant amount of testing, and had way too small hash tables for the number of threads. I believe the percentage of draws would have been much higher in a match with more normal conditions." Hikaru Nakamura said, "I think the research is certainly very interesting. The concept of trying to learn from the start without any prior knowledge, so certainly it's a new approach and it worked quite well obviously with Go. It's definitely interesting. That being said, having looked at the games and understanding what the playing strength was, I don't necessarily put a lot of credibility in the results simply because my understanding is that AlphaZero is basically using the Google supercomputer and Stockfish doesn't run on that hardware. Stockfish was basically running on what would be my laptop. If you want to have a match that's comparable, you have to have Stockfish running on a supercomputer as well." Well, this is actually very wrong. But first, we need to look at what a TPU, tensor processing unit, is and how it was used in the match. Neural networks require massive amount of multiplications and additions between data and parameters. These multiplications and additions often organized into a matrix multiplication, which you might have encountered in high school algebra. So the problem is how you can execute large matrix multiplication as fast as possible with less power consumption. It is a domain-specific architecture. That means, instead of designing a general-purpose processor, it was designed as a matrix processor specialized for neural network workloads. TPUs can't run word processors, control rocket engines, or execute bank transactions, but they can handle the massive multiplications and additions for neural networks, at blazingly fast speeds while consuming much less power and inside a smaller physical footprint. So this means, AlphaZero used this TPU architecture when it was playing with Stockfish. It is not an apples to apples comparison for sure, but still let's try to compare it. AlphaZero used 5,000 first-generation TPUs to generate self-play games and 64 seconds-generation TPUs to train the neural networks, but it used a single machine with 4 TPUs to play with Stockfish versus Stockfish's 64 threads and 1 GB of hash for the first match. For the second match, the paper has this section. To evaluate performance in chess, we use Stockfish version 8, official Linux release, as a baseline program. Stockfish was configured according to its 2016 TCEC World Championship Superfinal settings: 44 threads on 44 cores, two 2.2 GHz Intel Xeon Broadwell CPUs with 22 cores, a hash size of 32 GB, endgame table bases, at 3-hour time controls with 15 additional seconds per move. We also evaluated against the most recent version of Stockfish, Stockfish 9, using the same configuration. It was just released at time of writing. But what about the power consumption? Surely AlphaZero must be consuming tons of electricity to win against Stockfish, right? Not exactly true. It is true that training neural networks consume a lot of energy during the training phase, but when AlphaZero was playing against Stockfish, electricity consumption was exactly the same. Google's 4 TPUs were consuming 300 watts and 2 Intel Xeon Broadwell CPUs were also consuming 300 watts. With this setting, results were closer, but still, AlphaZero managed to beat Stockfish. Yes, a lot of machines were used to train AlphaZero, but just think about how many CPU hours went into training Stockfish. How many chess masters and programming wizards worked tirelessly on the program to fine-tune hundreds of parameters, and tried to squeeze the last bit of performance from the hardware for years by trial and error. And here we don't even count the theoretical knowledge accumulated for more than 1,000 years. All of this was crushed by good engineering, and genuine algorithms and only a few hours of self-play. Simply, beating Stockfish was the unachievable target at the time, but DeepMind team managed to do that. So the answer to the question, did AlphaZero cheat? Is a no. AlphaZero didn't cheat, it was just using a better algorithm and clever engineering to beat Stockfish. This is a very interesting part from the paper. Finally, we analyze the chess knowledge discovered by AlphaZero. Table 2 analyzes the most common human openings, those played more than 100,000 times in an online database of human chess games. Each of these openings is independently discovered and played frequently by AlphaZero during self-play training. When starting from each human opening, AlphaZero convincingly defeated Stockfish, suggesting that it has indeed mastered a wide spectrum of chess play. Today in NNUE. Today, Stockfish is much stronger with its efficiently updatable neural networks. Compared to normal evaluation, NNUE computes the position value with a neural network based on piece positions only. The network is optimized and trained on the evaluations of millions of positions at moderate search depth. This means that at least a part of AlphaZero is living in Stockfish and making it stronger than ever.